let's start with the very first radical, which is the cube root of 54x y to the third.
Which quiz number was this?
I'm sorry?
The quiz number?
Oh, this is quiz 10.
Okay.
Okay? So we know that we have to split it, as we always did. And we know that this cannot be further simplified. And we know that this is very clear what?
What?
Yes.
Well, that was easy.
Good. So now here I look at the prime factorization of this number. 54, it's an even number, so it must be divisible by 2. 27. And I already know that 27 is a perfect cube. It's 3 times 3 times 3. So at this point, I know that 54 has to be split into 2 and 27. I already have the simplified form of the first radical. Can anyone tell us the simplified form of the first radical? 3. There is no square root here. 3y. And this is left over and this is left over, and they have to be under what root? Yes, 2x. I'm sorry?
Where did 3 come from?
The cube root of 27 is 3. The cube root of y cubed is y. We can get a little bit more time, but I have to finish, and this is going to be a test next week. So I really want you to be a little bit faster. I really want that. I have no problem with giving more time on quizzes. They're just two problems. Okay, is this clear? Is the first simplification clear? Which part is not?
The whole thing.
Do you understand that
The only thing I get in that whole situation is y.
but do you understand that we have to split it? It's one rule.
Yes, I get that.
Yes, Ryan and Katie, please. Please allow me to respond, please.
I don't understand how you went from, well, I get that you split 54 and 227, but, like, why is the 2 over there? Like, I don't understand.
So, okay, so do you understand that this is the cube root of 2 and the cube root of 27 and the cube root of x and the cube root of y cubed? Is this clear?
Yeah.
Is it clear that this will be 3 and this will be y? And is it clear that these two have to stay under the cube root because I can't simplify them?
Yeah.
Okay, so these two are here, this one is here, and this one is here.
Okay, well, like, it's not that easy when you're trying to get all of this in, like, 2 minutes. It takes 2 minutes to do that part alone.
Okay,
Like,
but we did this last time. So I'm hoping that from class to class you are going to read the notes and watch the videos and do the practice. I'm really hoping that you're going to do that because we are not going to be able to finish. Okay, so now the next one is the cube root of 2xy cubed, which is the cube root of 2, the cube root of x, and the cube root of y cubed. Only y goes outside from here. So it's y, the cube root of 2x. Is this clear? We understand the second one. Okay, now the third one is y and the cube root of 128 times x. So this will be y, the cube root of 128, and the cube root of x. Like before with 27, I don't know what 128 is. Let's say 54, I meant, not 27. So 128, it's an even number. It must be divisible by 2. And when I divide by 2, I get 64. And I know that 64 is a perfect cube. So I will rewrite everything as y, the cube root of 2, the cube root of 64, and the cube root of x. I know that this is 4. So the simplified form of the third radical is 4y, the cube root of 2x. Is this clear?
So the y always goes on the outside?
It was outside. I didn't do anything to it. This is the term that we had. This is the third one. You're talking about the last one? Well, the last one had y in front. At the other ones, it happened that the cube root of y cubed is y, and it went in front. Yes, if that's what you meant. The same thing here. There was a y that was coming out because of the cube root of y cubed. As long as these two numbers are the same. If you remember, the first property we discussed is this. So that's why 3 over 3 is 1. Is that better? Okay, so now we have all these three radicals. So I'm copying the problem from the beginning. So here it is. So the first radical was simplified to 3y the cube root of 2x. The second radical was simplified to negative y the cube root of 2x. And the third radical was simplified to 4y the cube root of 2x. And now, like we did last time, we have to analyze what we have. So I'm analyzing, and I see that this is the same in all three, which is the irrational part. I see that they have the same variable in front and the same power of the variable, which means that all these are like radicals. And I can say 3 minus 1 plus 4. So that's 7 minus 1, which is 6y, the cube root of 2x. Last time we did way more difficult situations. I can show you. I have it right here, if Jason will allow me to. Way more difficult. So look at all this. Look at all this. Way more difficult. Look at all this, where we had to split everything, even numbers and variables. Here we didn't even have any variables to split. Look at this problem. It's way more difficult than what we had on the quiz, and this was last time. So I'm hoping that from class to class my students go over what we do in class and study that so we can move on. That's my hope. Okay, and the last one. Do I have to do the second one since we did the other one a few minutes ago? Okay, so first of all, because the denominator has plus, you cannot multiply and divide by plus. It has to be the conjugate. So it's 2 to the square root of a minus the square root of b, 2 to the square root of a minus the square root of b. And if you go to your notes, you will see it says conjugates. You cannot have the same quantity. So then the denominator is easy. So this is just 4a minus b. Now the numerator, 2 to the square root of a times 2 to the square root of a is indeed 4a. 2 to the square root of a times negative the square root of b will be negative 2 to the square root of ab. Negative 3 times 2 is negative 6 the square root of a, and then positive 3 the square root of b. And this is final. There is nothing else. Any questions? Any questions? Okay. We are trying to finish up chapter 10. So we need to practice more from 10.7. And also, on Thursday, we are going to review for the test. So we are back on page 630. And we looked at, what was the last problem? If you could just tell me what was the last problem we looked at.
Number 39.
Number 39. Okay. So let's work on problem 41. We'll go back to more examples. So on page 630, the cube root of negative 6x minus 1 equals the cube root of negative 2x minus 5. Let's work on this problem together. Any suggestions on how to solve this radical equation?
That's equal to second.
Yes, the cube root of negative 6x minus 1 equals the cube root of negative 2x minus 5. Problem 41 on page 630. We cannot.
Oh, yes.
The cube root of a sum cannot be simplified in any way, shape, or form, or a difference. Nope. I can multiply by 10, but it was not going to help.
Just cube each side.
Wonderful. That's the trick. To cube both sides to eliminate the radical. Good. When I cube the left-hand side, what do I get? Very good. When I cube the right-hand side, what do I get? What type of equation is this right now? What type of equation is this? Very good. It's a linear equation. How do I solve a linear equation? What do I need to do? Excellent. So I have to have the variable on one side and everything else on the other. Can anyone tell us what will be the next step? It doesn't matter where you want to keep the variable. I prefer the left-hand side, but it doesn't matter. Finish it in your way, and we finish it like this, and we'll check the answers. Do you have to get the same answer? We have to get the same answer. So if I move negative 2x to the other side, it becomes positive. What do I have on the left? Very good. If I move negative 1 to the other side, it becomes positive. What do I get? Good. Finally, I divide both sides by negative 4, so I get x equals 1. Remember, it comes with a question mark. We discussed that last time, and let me refresh your memory. When we raise both sides of an equation to the second, the third, the fourth, the fifth power, it's mandatory to go back and check. Now, here's a little inside information, if you want. Every time we raise to an odd power, all solutions will work. Whatever we get, they will all work. But I still have to show that I checked to make sure. So this is the cube root of negative 6x minus 1, and this is the cube root of negative 2x minus 5. And I am checking 1. So how much is negative 6 times 1? Negative 6 minus 1? Negative 7, perfect. Negative 2 minus 5? Are they the same? Will you accept x equals 1 as a solution? Yes, of course. Very good. Okay, let's look at 17. I don't remember if we did 17. You can stop me if you say yes, we did 17. Or let's do 15. For sure, we didn't do 15. Okay, the square root of 13 minus x equals x minus 1. Any questions? Any questions?
So let's say negative 6x minus 1.
Yes, so it's negative 6x minus 1 from the beginning and negative 2x minus 5. Yeah, I'm checking myself as well. So I copy negative 6x minus 1 and negative 2x minus 1. Okay, so what do you recommend we should do here?
Same page.
Same page. Everything is from 6:30. Yep. Say it again. Very good. Perfect. Remember, we wrote a note. We cannot square term by term. So the left-hand side is 1 unit and the right-hand side is 1 unit. Now I'm ready. When you are. 13 minus x, I agree. The right-hand side. We have a contract. X squared. Say it again. Minus 2x, very good. Sign? Very good, excellent. Indeed, first term squared minus 2 times the first times the second plus the second term squared. Excellent. What type of equation is this? So I know what to do. Excellent. Quadratic. How do I solve a quadratic? Yes, please. Jonathan? Sure. Good. So what do I do with the quadratic equation? How do I solve it? What is the idea? Very good. I have to set it equal to 0. Perfect. Good. So I have x squared.
X.
So very good. Minus x. And then? Excellent. Any questions on this? So we moved negative x to the other side by adding x. So x squared, negative 2x plus x is negative x, and 1 minus 13 is negative 12. Now what?
Oh, so that's on there.
Very good. Yes, Brianna?
I have a question.
Yes.
Did you set it equal 0 because it's a quadratic?
Yes. Yes. That's why I'm asking. Very good. So that's why I asked here what type of equation it is, because in a linear I have to separate the variable from the rest. In a quadratic, I have to set it equal to 0. Okay, so then what follows now? Say it again. I can't solve a quadratic equation if I have something on the other side. Yes. So then, that's why we said it. We have to set it equal to 0. I can't solve. That's why the linear equation requires separation, and the quadratic equation requires 0 on one side.
X minus no.
So there are two possibilities. Can anyone tell us those possibilities?
X equals 4.
Correct. Excellent. But they both come with a lot of question marks. Why?
You have to test it.
Yes. So I have the square root of 13 minus x equals x minus 1. So this was the equation, so I just copied it. And I like that very much. Test it. That's better than check, I think. Very good. I have to test it back in the original equation. I like that. Can I use it?
Yeah.
Because sometimes you have to pay royalties to use an idea. I'm kidding. Okay, so I'm checking 4. 13 minus 4. 9. The square root of 9. So the left-hand side is 3. What about the right-hand side? Will you accept x equals 4? Now I have to check negative 3. (13 minus negative 3). The square root of 16. Negative 3 minus 1. Very good. Yes. X equals negative 3 is an extraneous solution. extraneous solution.
Extraneous.
Yes. Very good. I will not test you on equations, radical equations that have two radicals. But I would like you to choose one so we can do one in class, because I may have it on as homework, but I will not put it on a quiz or test. Maybe a extra credit to choose from, but not mandatory. So let's choose one with two absolute values, with two radicals and another term. Like, for example, 49 on 630. Ready? So in 49 we have the square root of y plus 3 minus the square root of y minus 3 equals 1. Would you agree that this is different than all the other radical equations that we looked at before? Except you can say, but what about this one? This one has two radicals as well. How is this different? Very different. Why? Because this one has only two radicals and no other term. This one has two radicals, but it also has an extra term. So they are very different. And they will be solved totally differently. More steps, in other words, I meant to say, for this one. So it is wise to separate the radicals if you have two radicals in a radical equation. So if they are both on one side, I will take one to the other. If it's negative the square root, when I move it to the other side, will become positive. So I have the square root of y plus 3 equals 1 plus the square root of y minus 3. It is easier to square it in this form than to square it when both radicals are on the same side. Okay, the left-hand side is easy. The left-hand side? Very good, excellent. But the right-hand side requires the contract again. Here it is. The first term squared plus 2 from the formula. 2 times 1 times the square root. 2 times 1 times the square root plus this squared. Yes? Very good. And plus? Very good. So we square the first term, plus 2 times 1 times the square root, plus the square root squared. Yes, please, Michael.
The formula you showed, is that a name?
It's a binomial. It's a trinomial perfect square trinomial.
Perfect square triangle.
Okay, this was discussed in the previous course. I'll show you where. In chapter 5 and chapter 6. Here it is. On page 394, a plus b everything squared is a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. And these are perfect square trinomials. Page 394 in chapter 6. Okay, so let's continue now. From a radical equation with two radicals, it kind of collapsed into a radical equation with one radical. What do you think we have to do next? Right, I will subtract one, but you mean how we got from here here?
Yeah.
The first term squared plus 2 times the first times the second.
I thought in between those two it's subtraction.
It was negative on this side. When I move it to the other side, it becomes positive.
I mean, in the can you show the formula?
There are both possibilities right here. With if it's minus here, it's minus here. If it's positive here, it's positive here.
Yeah, between a squared and b squared.
I did not show this. You want me to look for that?
Yeah.
Okay. You don't believe that it's in here, or you just want to see it in the book, or is that?
Because like in the book.
Oh, okay. Here it is. On page 403, a plus b times a minus b is a squared minus b squared. I'm sorry?
So the formula he was asking about, you said it was like the perfect square triangle.
That was the other one. I thought you were asking about this. You're asking about this?
I was asking about what you showed us.
Right now or before? Before, okay. Let me go back. A plus b squared equals a squared plus 2ab plus b squared.
And then a squared.
A minus b squared is a squared minus 2ab plus b squared.
So doesn't that mean between the two, it's a squared minus 2ab?
You mean here?
Yeah.
Only if this is negative.
Isn't it negative as well?
Okay. We moved this term to the other side. It was negative here. When I move it to the other side, it becomes positive. Is that what you meant?
I'm looking, my bad, I was looking in between the 1 minus 3.
But this quantity is the b, and this quantity is the a.
Yeah.
So a squared is 1 plus 2 times a times b. 2 times a times b plus b squared, which is this. So the square root squared is y minus 3. But you cannot touch anything inside. So when you multiply 2 by 1, 2 by 1 times the square root, you cannot change anything inside the square root. It's a very good question, actually. So this is 2 times the square root. You cannot change anything inside. You are not putting anything inside. If you're not asking questions, then I would not know what to, what things I should clarify. But now makes sense. So when you multiply these two, if you remember, when I multiply the square root of 2 by the square root of x, this is the square root of 2x. I'm not changing anything inside. If I have 3 times 2 times the square root of x, I have 6 the square root of x. But I could have the square root of 2 times the square root of x minus 1, which is the square root of 2 times x minus 1, which I can't change anything inside. So when you square, this does not change inside. It either clears completely of radicals, or it keeps the square root of y minus 3. Better? Good. I'm glad we clarified that. Okay, so we are back to our equation. This is the equation now. It has only one radical. What would you recommend we do? I can't. How will I square 3 terms? It will be a mess. I will have 6 terms, and I will never get rid of the radical. So when we have a radical equation with one radical, what is the first step that we have to perform? So that I can get it ready to square. How do I do that? I need to isolate the radical. I need to isolate the radical, right? This is what we did on all equations with one radical. We isolated the radical, getting it ready to square it, right? How can I square like this? I will never finish. So then the right-hand side has only 2, the square root of y minus 3. Can anyone tell us what the left-hand side will have? So this is here. This has to go. This has to go. This has to go. So there is a 1 minus 3, which is negative 2. Right? Negative 2. When I move it to the other side, I get. Right? Because 1 minus 3 is negative 2. When I bring it to the other side, I get 5. What happens to y? Y goes away. So this is our new equation. Say it again. This one?
Oh, that's the whole thing.
It's multiplied. It's 2 times a times b. I cannot separate 2 from the square root because it's multiplied. Is that clear?
So you can't divide it?
I'm not ready. I'm not there yet. Would you divide both sides by 2 if you have all these? Not yet, right? Okay, so I copied the radical. I subtracted y from both sides. 1 minus 3 is negative 2. Negative 2 brought to the other side is 5. Would you agree with this step? Is it a yes? Is it a no? Okay, what will be the next step? How? Say it again. Yes. Now we're ready to square both sides. Good. The left-hand side. Perfect. The right-hand side. Right. And in parentheses? Very good. I agree. So now this is 25 equals 4y minus 12. What next? I'm adding 12. Very good. So I get 37 equals 4y. So y appears to be, it appears to be 37 over 4, but it comes with a big question mark. So what do I have to do next? Yes. So let's plug it in. I'm still in chapter 6. Very good. So back to the original problem. I'm going to copy the original problem right here. So it was the square root of y plus 3 minus the square root of y minus 3 equals 1. And we are checking 37 over 4 plus 3 with the square root minus 37 over 4 minus 3. Any questions so far? Are we okay? Okay. The least common denominator in the first radical. So then that's 37 plus.
Oh, I know. It's 12.
Good. I have to multiply by 4. So plus 12 minus the least common denominator in the second radical. Good. So this will be 37 minus
12.
Good. Perfect. So 37 plus 12 is 49. 37 minus 12 is 25. I know how to split this. This is the square root of 49 I learned in this chapter over the square root of 4 minus the square root of 25 over the square root of 4. And then this becomes good minus, which is 1. Which one? This is the original problem. I just copied it one more time.
Yeah.
This one?
Yeah.
Oh, I'm not doing anything to it. I just replaced everything, and I showed step by step that I'm getting 1 when I replace x by 37 over 4. I cannot say it's 1. I haven't got to that. So I'm starting with the left-hand side, and I show step by step that this is indeed 1, and then I'll say since it equals the right-hand side, then I will have to accept 37 over 4. Okay. Okay, so just remember these equations require a lot of work. Just solving 1 or 2 or 3 is not going to be enough for you to be able to solve these on your own. Any questions? Say it again, Tanya.
No, it's just wondering if this would be
And I already said if it has 2 radicals, no. It will probably be like an extra credit situation if you want. Okay? So let's continue then. I have to finish. I have 5:25. I have to finish this chapter today so we can have the test next Tuesday. Say it again. Okay, so let's talk about the Pythagorean theorem. I'm sure everyone knows it. It doesn't matter how you denote the sides. Let's say A, B, C. And we know that the hypotenuse squared equals the sum of the squares of the legs. So we're going to be using this in several triangles. Let's look at 53 on page 630. And we are given the following triangle. The hypotenuse 7 meters, one leg 3 meters, and the other one unknown. Can anyone dictate what is the Pythagorean theorem? How will it look in this particular? Very good. 49 equals 9 plus?
Square.
Very good. So the hypotenuse squared equals one leg squared plus the other leg squared. All I have to do now is subtract 9. So then x squared equals 40. I'm sorry?
Then you have to get rid of the square.
Yes, please. Rebecca?
Why isn't it a squared plus b squared equals c squared?
It doesn't matter how you want to call them. So if you want to call this A and you call this B and you call this C, that's fine. Then you'll have A squared plus B squared equals C squared. It doesn't matter how you denote them. As long as the order is always the same, meaning the hypotenuse squared is the sum, that's fine. Don't denote them the way you like. It's not important. Okay, so now let's talk about the principle of square roots. Okay? No, it's still in this chapter.
Yeah, so like,
It's still in this section. Yep, still in. I'm sorry? No, in order to finish this problem, I have to talk about the principle of square roots, and we'll come back and finish it up in a minute. So, assuming I have the equation x squared equals 4, and I apply the square root to both sides, what do I get on the left-hand side? And remember, x can be any real number. What do I get on the left-hand side if x is any real number? And we studied this in this chapter.
The absolute value of x.
Excellent, thank you. How much is the square root of 4?
Sure.
2. But we know from this chapter that, actually from chapter 9, to be exact, we know that this equation now, how to solve this equation, is we know that it has how many solutions? Exactly, and the solutions are x equals. Very good, excellent. So what we normally do, but I needed to show you all the steps. What we normally write is this: x squared, the square root of x squared, and the square root of 4. And we immediately go to the final answer as being plus or minus 2. This is the correct intermediate step. I don't want you to think that the square root of 4 is plus or minus 2. No. The square root of 4 is not plus or minus 2. Where do these two symbols come from? They come from the absolute value. They come from the left-hand side, not from the right-hand side. So the principle of taking square roots is this. If I have x squared equals a number, and I take the square root, I omit the important step in between, which is the absolute value of x equals k, and we automatically write plus or minus the square root of k. So this is the principle of square roots. But please remember there is an intermediate step in there that creates the plus or minus. Now we're ready to finish up this problem. So we had x squared equals 40. As you mentioned, very good. You said take the square root from both sides. So then I will have to write x equals plus or minus. How do I split 40 into a perfect square and something else that is not a perfect square?
5 by 2.
4 and 10, right?
Yes.
So this will be 2 the square root of 10 meters. However, because we're talking about the length of a side of a triangle, I cannot accept both solutions. Which one will you accept? Which one? Only.
Can you move it up a little bit?
Which one are we going to accept? The one with the plus or the one with the minus? Of course, it's a distance, right? So I will say no. Just x equals to the square root of 10 meters.
That's because it doesn't have absolute value.
It has, because it's a distance. Because it's a distance. It cannot be negative. I cannot say to you that the distance between me and you is negative 10 feet. I have to say it's 10 feet. Yes? Okay. Other questions here?
How
Anyone?
did you get 2 times the square root of 10 for 40?
Okay. We learned in this chapter that we can split the square root of 40 as the square root of 4 times the square root of 10. And this is 2 times the square root of 10. Better? Is that better? Okay. Okay, so my page 9. Moving on, let's take a look at, 56. Say it again, please. Thank you. So one is 5 the square root of 3 centimeters, and the other one is 10 centimeters. Please find the hypotenuse. Yes?
You said 5 square root of 3.
5 the square root of 3.
What's the one on the bottom?
10 centimeters.
Okay.
Good. Say it again.
Look for hypotenuse.
Say it again.
What is the one to solve for?
What do you think?
Distance?
What do you think?
LC or whatever.
Right, it's the hypotenuse, right? We denote it by x, but you can denote it by anything you want.
So square
Thank you.
plus 1 square
Very good.
plus square.
Very good. Thank you. So now I have to square 5 the square root of 3. What do I get? 25 indeed. Times 3. Very good. Plus 10 squared. Very good. And that is x squared. How much is 25 times 3? 75. How much is 75 plus 100? Good. What do I do now? Because I know the principle of taking square roots. Take the square root, and the answer should be x equals plus or minus the square root of 175. I have to simplify that. So I take 175 aside. I see it ends in 5, so it must be divisible by 5. What else? So 15 divided by 5. So I should say 17 divided by 5, which is 3, and in 25, 35. And then 5 and 7. So then, of course, I will not accept both. So the simplified form will be x equals.
You don't have to break down 175, is that?
Yes, because we learned in this chapter that we know how to simplify. We learned how to simplify the square root of 175.
I got a question.
Please.
So let's go back up to where it says 25 times 3 plus 100.
5 squared is 25. The square root of 3 squared is 3. When I have a product that I need to square, I have, okay.
My question is how do you bring back up the square root? What's the rule on that? I know there's.
So this is 75 plus 100 is 175. So x squared equals 175. And I apply the square root on both sides based on the principle of square roots.
Okay. So, like, is that like the final piece of it?
We didn't finish. We have to simplify the square root of 175. So first I show that I'm taking square roots from both sides. Then I'm using the principle directly that says that the square root of x squared is x and the square root of k on this side, but it should be the absolute value. Instead of writing the absolute value, I have plus or minus. So when I take the square root from both sides, it's quadratic. I have to find 2 solutions. So I get plus or minus the square root of 175. But the square root of 175 is not plus or minus the square root of 175. As we know, there is an intermediate step that we skip. Okay, perfect. So then what is the simplified form? Of course, just the plus because it's a distance.
That was what I was referring to.
So 175 is 25 times 7. So this is the square root of 25 times the square root of 7. That's why I presented the prime factorization of 175. So then the simplified form will be, yes, square root of 7 centimeters. Of course, if you want to approximate this, you can. So you can put in the graphing calculator and just say the square root of 175, and that's approximately 13.23. No, this will be a requirement. You wanted to factor out 25 here? You could. Here?
by 7 from the beginning instead of breaking it by 5 and then multiplying it by 5.
You can do anything you want, but I always, when I present the prime factorization, I start with the smallest prime factor that goes into a number. But it's not a mistake to start with 7. But how will you see it? Do you see from here, if I say 175, is it 175 divisible by 7? Will you know?
Well, I just sort of did it.
You saw it after, yeah, but you saw that after we divided by 5 and divided again by 5. I think it's difficult to see that 175 is divisible by 7, but if you see that, that's perfect. That's fine. But we normally start with the smallest prime number till you exhaust all prime numbers. But I accept any method that works for you. Any questions? Oh, say it again.
I don't like this.
Good. I'm so happy that you see that, and yes, you will. Okay, so let's look at number 61, which is a word problem. And we have this situation. And it says a spotlight is mounted on the eaves of a house right here. That is 12 feet above ground. A flower bed runs between the house and the sidewalk, so the closest a ladder can be placed to the house is 5 feet. How long of a ladder is needed so that an electrician can reach and place the light on the eve of the house? This is one for you. I promise Jason, every time we get the chance, you're going to have something to work on, and I have to keep my promise. 2 minutes.
Is this like just pretty much the same